First thing we're going to do is we're just going to try to find kind of trig values with dealing with sine, cosine, and tangent. So here's kind of the thing you have to memorize. As long as you memorize these values, you should be fine. And yeah, so notice how cosine of x, or cosine of x, sine of x, just write this down. So any point on the unit circle can be defined as cosine of x, sine of x. So notice the cosine values, which represent the x value. So the cosine value represents the x value, sine value represents the y value. And you see a sort of pattern here. For cosine value, it's 3, 2, 1. Just memorize 3, 2, 1 for cosine, right? Cosine of 30 is radical 3 over 2, 45 degrees, radical 2 over 2, 60 degrees, radical 1 over 2, and then for sine, it's just the opposite. It's 1, 2, 3. All right, let's do some practice problems. So here are 5 practice problems, and feel free to try. So how do we do this? Cosine of 330 degrees. Now, a 330 degree angle on the unit circle looks something like this. So you're going to graph out your unit circle, draw out your unit circle, and 330 degrees is going to be at quadrant 4. Because, right, you have 90 degrees, 270 degrees. 330 is greater than 270, but it's less than 360 degrees, which is just one full rotation. So, therefore, it's going to be in quadrant 4. This is going to be a 330 degree angle. Now, this angle right over here is going to be 60 degrees. Think about it, right? You made a 330 degree rotation. And we know that a whole loop around the unit circle. So this angle right over here is just going to be 30 degrees. This one. Because notice how these two angles right over here add up to 360 degrees. Right? Because one full rotation around the unit circle is 360 degrees. So if this angle right over here is 330, then this tiny angle has to be equal to 30 degrees because they add up to 360. You just draw an altitude down. And then after that, you could just do your 30, 60, 90 right triangle. So in this case, the hypotenuse of your triangle is always going to be 1 because it's a unit circle. So that, this is representing, this right over here represents the radius of the unit circle. So therefore, this side's going to be 1/2. This side's going to be root 3 over 2. And then after that, the x value is root 3 over 2, but we're trying to find the y value, which is, so the x value is root 3 over 2. If we were trying to find the sine value, which represents the y value, it would just be negative 1/2. Because remember, you're going 1/2 units down, right? And we're trying to find a coordinate at this point. So 1/2 unit down is going to be negative 1/2. Sine of 135 degrees, once again, then do the same thing. Draw out your unit circle. 135 degrees looks something like this, right? It's going to land in the second quadrant because it's in between 180 degrees, but it's greater than 90 degrees. So if this is 135 degrees, this angle right over here is 45 degrees because this whole thing is a half of the unit circle, so it's going to add up to 180 degrees, right? So now all you have to do, just take this point right over here where it intersects the unit circle, draw an altitude down, and this is 1, so this has to be root 2 over 2. This has to be root 2 over 2 for the y value. Y value is just going to be root 2 over 2. Because the y value in quadrant 2 is positive, right? If you're in this section of the unit circle, notice how the y value is positive, right? For any point. Tangent of 240 degrees. So, once again, draw your unit circle. 240 degrees is in quadrant 3, okay? Now, if this is 180 degrees right over here, and this whole thing right over here is 240 degrees, then this tiny angle right over here has to be 60 degrees, right? Because 180 plus 60 gives you 240. So once again, this is 60 degrees. Draw your point here, draw an altitude downwards. And yeah, so this is going to be 1/2. This right over here is going to be root 3 over 2. Now, the thing is, all right, so the x value right over here, the cosine value, so in this case, cosine of 240 degrees is going to be equal to negative 1/2. Because cosine represents the x value of this point right over here. And in this case, we're going negative 1/2, right? This way. So for your sine value, it's going to be equal to negative radical 3 over 2. Because remember, the y value is also negative in this case. Tangent of an angle is equal to sine of that angle over cosine of that angle. So in this case, tangent of 240 degrees, if I have tangent of 240 degrees, it's going to be sine of 240 degrees over cosine of 240 degrees. So sine of 240 is negative radical 3 over 2. And we're going to divide this by cosine of 240, which is negative 1/2. We can keep change flip. Negatives cancel out, 2 cancel out. You're just going to be left with radical 3. All right, tangent of 315 degrees. So once again, I'm just going to draw your unit circle. 315 degrees is going to land somewhere here, right? This is 315 degrees. If this is 315 degrees, then this angle right over here has to be 45 degrees. All right, so it's gonna hit the unit circle at this point, drawing out 2 downwards, and then after. Hold on, let me just redraw this. So this is 315 degrees. This is going to be 45 degrees. Drawing out 2 downwards. So then after that, this is going to be root 2 over 2. This is going to be root 2 over 2. However, because we're in the 4th quadrant, our sine value is going to be negative. So in this case, our cosine value, our x value in this case, is going to be, so cosine of 315 is equal to root 2 over 2. And then sine of 315 degrees is going to be negative root 2 over 2. Because remember, we're in quadrant 4. So in this case, right, right over here, we're going root 2 over 2 units downwards, right, to this point. And if we're going down, then that means our y value is going to be negative. So now just take this value divided by this value, because remember, we're trying to find out tangent. We're trying to find out tangent of 315. Tangent is sine over cosine. So in this case, sine over cosine, once you do this, you'll get negative 1, which is tangent of 315. Okay. Finally, we have sine of 7 pi over 6. If it helps you, you can convert this to degree mode. I mean, you can convert this to degrees, but I'll draw it out. So in this case, 7 pi over 6. Now, you can break this up, right? You can say this is, this can be 6 pi over 6 plus pi over 6, right? We can say 7 pi over 6 is equal to 6 pi over 6 plus pi over 6, right? So we just break this up into 2 parts. So 6 pi over 6, this just cancels out to pi plus pi over 6. Okay. So imagine if we originally started with pi over 6. Well, if we add pi to this, so imagine if we add pi to this, pi right over here, right? Pi represents 180 degrees. So imagine if you add 180 to this, well, this angle plus this angle is going to give you 7 pi over 6, right? This angle plus this angle is going to give you 7 pi over 6, which represents this big angle, right? Now, this angle right over here is the angle we want to find. That's our reference angle, okay? So what's our reference angle going to be in this case? What is our reference angle going to be? Well, in this case, our reference angle is just going to be pi over 6. Right? Imagine if you took this angle and you just added 180 to it. Well, it's just going to land here, right? You're just going to land it here, right? So it's the same angle. Pi over 6 is the same thing as 30 degrees. So you can do your 30, 60, 90 right triangle here. And our cosine value is going to be negative root 3 over 2, right? So we're trying to find the sine of 7 pi over 6. So right over here, sine represents our y value. So that means that it's just going to be negative 1/2. Because remember, if we're in the 3rd quadrant right over here, everything is going to be negative. So, right, we're going 1/2 units downwards. And that's going to be the answer. Okay, angle theta is in standard position and is a point on the terminal side of theta. What is the exact value of cosine of theta in simplest form? So standard position, all this means is that it's sort of like, you know, what you've been doing with the unit circle. All it means is that the angle is created with the x-axis, okay? And it's on the terminal side. It's a point on the terminal side of theta. So the terminal side of an angle represents, in this case, it's like kind of the thing you draw to create the angle. So in this case, we drew a ray to create the angle, so this would be the terminal side of the angle. Now it says it's at -6, -4. So -6, -4 is somewhere over here. So let's just say, I don't know, this right over here is -6, -4, and okay, it creates this angle. Okay, now in order to find cosine of theta, well, what you have to realize is that cosine, right, when you're doing like unit circle problems, right, let's say if we want to find sine of 135, for example, right, the practice problem that we did, well, 135 degrees is right here, right, and what we did was we actually only cared about the reference angle. So the reference angle is 45 degrees, and then we found out that sine of 135 is equal to √2/2, right? Now, it turns out that sine of 135 is equal to sine of, in this case, the reference angle, okay? So the important point I'm trying to make here is that if you have sine of an angle, it's going to be equal to sine of the reference angle. All right? And we know that the reference angle is just going to be this acute angle that's created with the x-axis. So in this case, my x-axis is here, right? And it's going to be this acute angle that's formed with the x-axis. So in this case, cosine of our angle is going to be equal to cosine of this little angle right over here. We can call, I don't know, let's call it θ2, okay? θ2. All right, so now what we're going to do is, well, we know that our x value is -6, right? So in this case, we go -6 in the x direction. So in this case, we go -6 in the x direction. In the y direction, we go -4. So -4 is going to be right over here. Cosine is equal to the side, cosine of theta is going to be equal to the side adjacent the angle over the hypotenuse. Now, in this case, we don't know what our hypotenuse is, so we can just use the Pythagorean theorem. A squared plus b squared is equal to c squared. Just call this side c squared. So we're going to have 16 plus 36, which is 52. It's equal to c squared. We just square root both sides, and we get that c is equal to plus or minus the square root of 52. In this case, we're just going to stick with the positive answer. Okay? Sticking with the positive answer because it's a triangle. In this case, cosine of this angle right over here, or θ2, is equal to the side adjacent this angle, which is -6, over the hypotenuse, square root of 52. Now, can I simplify this any further? So what I'm going to do is I'm going to first rationalize the denominator, meaning I'm going to multiply the top and the bottom by our thing inside the radical. So I'm just going to multiply the top and bottom, so I get -6 radical 52 over 52, right? Because two things multiplied, and square root's going to cancel out. Now, 52 is equal to 2 times 626, which is equal to 2 times 13. So I can actually simplify this into -6 times 2 radical 13 over 52, radical 13 over 13. So like the main idea to know, so that's going to be our cosine value. So the main idea to know is that our reference angle is just going to be, cosine of our reference angle is going to be cosine of that entire angle, and that, whenever you're graphing these types of points, you can always create a right triangle, right, represented by the coordinates of the points, right, where the sides are like the coordinates of the points. And then you can just use Pythagorean theorem, and then it's all good. Now, for those of y'all who might be confused on why is the hypotenuse positive, so why is the hypotenuse positive, and why are the other sides negative? Well, think about it like this, right? If we just have a regular old triangle, all the sides are going to be positive, okay? So all the sides are going to be positive in a regular triangle. However, when we're dealing with coordinate geometry, right? Imagine if we're dealing with coordinate geometry, well, in this case, we use negative numbers to denote the sides. So in this case, this side would be negative, right? Because it's in the negative x-axis, right? And then this side would be negative because it's in the negative y direction, right? our hypotenuse is going to be positive because remember, the hypotenuse of a right triangle is equal to the square root of a squared plus b squared. And, this basically represents a distance. So in this case, right, the hypotenuse represents the distance from the origin to, the endpoint, right? So it represents a distance, and distances can't be negative. So that's the reason why the hypotenuse has to be positive, right? If you look at the distance formula, for example, the distance formula is literally, so it's going to be, this is the distance formula. Sorry. This is the distance formula, and the distance is always going to be positive. And so is the case for the hypotenuse. In which quadrant is sine of theta greater than 0 and cosine of theta less than 0? So what you got to remember, here is this phrase. So what you got to remember is this phrase, all students take calculus. So in this case, all trig functions are positive in the first quadrant. S stands for sine. So sine theta is positive here. Tangent theta is positive here, right? Which matches up with t. And then cosine of theta matches here. And cosine of theta is positive here. And that kind of makes sense, right? Because the thing is, in your first quadrant, so this quadrant right over here, any x value and any y value are positive. So when you create like this right triangle to represent the trig values, you're going to have positive side, you're going to have a positive side, your hypotenuse is going to be positive, so the sine and cosine values there are going to be positive. When you're in the second quadrant right over here, notice how the x values are negative in the second quadrant. And we know that cosine of theta, well, remember when we draw out the unit circle, right? Cosine of theta in this case is always going to be negative, right? Because cosine represents our x value. In this case, our x value is negative. But in this case, right, our sine value is going to stay positive. So, yeah. Down here, tangent is going to be positive because, well, so let me just draw. Maybe it won't make sense if I just keep the unit circle here. So remember, if we create an angle right over here, you're going to create this right triangle, right? If we create an angle, we're going to create the right triangle. Now, for this right triangle, notice how our y value is negative. So in this case, sine of theta is negative. And notice how cosine of theta is also negative. So both sine and cosine are negative in the third quadrant. So we have a negative value, right? And we have a negative value. If we're kind of looking at a right triangle, right, our x value is negative, y value is also negative. We know tangents equal to the side opposite over adjacent that angle. So in this case, our reference angle is here. So the side opposite that angle is going to be a negative value. The side adjacent that angle, which is this side, is also going to be negative. Negative over negative is going to be positive, right? Because remember, tangents equal to opposite over adjacent, right? So your opposite side negative, adjacent side negative. It's going to make a positive value. In addition, tangent represents the slope of our hypotenuse. So that's kind of like another way to think about it. Tangent represents the slope of this line. All right. So in this case, our slope of a line is clearly positive, right? So that's another way you can think about it. And finally, cosine of theta is positive here because when you create an angle here on the unit circle, well, notice how our x value is positive, right? Our x value stays positive, but our y value, in this case, sine of theta, stays negative. So, in which quadrant is cosecant of theta less than 0 and cotangent of theta less than 0? Once again, all students take calculus. So in this case, cosecant, what you gotta know is that cosecant is 1 over sine of theta. And cotangent is just 1 over tangent of theta. Now, wherever sine is positive, cosecant will be positive. Think about that. If you have a positive sine value, 1 over a positive number is going to give you a positive number. Whenever sine is negative, well, cosecant would also be negative. All right. So wherever sine is positive, well, the cosecant will always follow the same sign as sine. No pun intended. cotangent is 1 over tangent of theta, and it basically follows the same rules as tangent of theta. When tangent of theta is positive, well, 1 over a positive number, this will also be positive. If it's negative, well, 1 over a negative number, this is also going to be negative. So what you got to know about the reciprocal trig functions is that kind of the trend here is that, they kind of follow the same kind of pattern as their counterpart. All right. Now, we want to find where, so basically what the question is asking us is, basically they want us to find the quadrant where sine of theta is less than 0, right? Because if cosecant of theta has to be less than 0, then sine of theta has to be less than 0, right? Using the logic I said before. And we want to find an area where tangent of theta is less than 0, okay? So remember, they always follow the same trend as their sort of counterpart. Now, where would that be the case? So when is sine of theta negative? That's the first question you got to ask yourself. Sine of theta is negative. Remember, when we draw the unit circle, sine of theta represents this y value. It represents the y value right over here. And sine of theta is negative when you're either in quadrant number 3 or quadrant number 4, right? Because all of the quadrant here, the y value is going to be negative, right? So first of all, I already know it's either going to be quadrant 3 or 4. Now, when is tangent of theta less than 0? Well, tangent of theta, well, from here, we know that tangent is going to be positive in quadrant 3. Therefore, the only option we have left is quadrant 4, which is going to be our answer. Right, because tangent of theta, remember using the same logic we did before, right? If we draw out like a right triangle in like the unit circle, tangent is going to be equal to sine over cosine. And in this case, both sine and cosine are going to be negative, so negative divided by negative makes it positive. So tangent is greater than 0 in quadrant 3, which is not what we want, right? We want to find an area where tangent of theta is less than 0. And in this case, quadrant 4 is the only option that we have left. And it makes sense because look, if you draw a triangle at quadrant 4, notice how your x value is positive, but your y value is negative. So tangent of this angle that you've created, so this would be the reference angle, so tangent of this angle would just be equal to opposite over adjacent. So negative over positive makes it negative. So tangent of theta would be less than 0, which means that, it follows both of these criteria. Okay, so whenever you're dealing with these types of problems, if you're dealing with reciprocal trig functions, kind of convert them into their counterpart. All right, so if cosecant of theta is less than 0, then sine of theta has to be less than 0 for this to work, right? So you just convert them back into like, using the reciprocal trig functions, right? Find their counterparts, and then all you have to do is you can use some logic here, or you can just draw this unit circle and kind of visualize, All right, so find the period, amplitude, and midline of this sinusoidal function. So the midline, all right, so in a sine function or a cosine function, right, you're going to have a maximum point and you're going to have a minimum point. The midline is just going to be the average between those two values. What's in between these two values? So in this case, my highest point is going to be 3, right? My lowest point is going to be -5. I'm going to take the average of these 2 points, and I'm just going to get -1. So -1, which is right over here, -1 is going to be my midline. And remember, the midline's an equation, so it's going to be y is equal to -1, okay? So that's going to be my midline, right? It's literally the line in the middle, right? Now, my amplitude is just the distance from the midline to the highest point. So in this case, if my midline is at -1, y is equal to -1, and my highest point is at 3, well, the distance from -1 to 3 is just going to be 4. So my amplitude is equal to 4. Finally, the period. Now, the period represents kind of when you complete one cycle in a sinusoidal function. So imagine if you have a sine, right? It's just the distance from, in this case, here to, let's say, here, right? It's when the wave completes one cycle. Notice how from this point, you're going downwards, right? And when it completes one cycle, notice how it's the same pattern, right? You go downwards, and this right over here would be another period, right? Because you complete one cycle, then you go downwards, right? So a period just represents, you're coming back to the same point after completing one cycle. In this case, right, this point right over here looks to be the same as this point right over here, right? So these 2 points, the distance between these 2 points represent the period. The distance between these 2 points represent the period. All right, so what's the distance between 30 and 5? well, that's just going to be 25. So that's going to be the period. All right, so based on this equation, how can we find out the values of A, B, C, and D from the graph? What you got to remember is that D represents the midline. C represents the horizontal shift. B represents your period. All right, B is equal to 2 pi divided by the absolute value of your period. And finally, A, the parts in front of the sign, that's going to be equal to the amplitude. Okay, so first, let's find the midline. That's what I always like to do first. Midline is just the average between the highest and the lowest points. So the highest point is 5, lowest point is negative 2. So the average is just going to be negative 1.5. Oh, wait. So the average is just going to be 1.5, I'm pretty sure. So that's going to be the midline. It's going to be, the midline is going to be 1.5. I mean, the midline is y is equal to 1.5, right? But in this case, our d term is just going to be 1.5 itself, okay? So 1.5, let me just draw this. So y is equal to 1.5. Now, remember, the distance from the midline to the highest point is the amplitude. In this case, we're trying to find the distance from 5 to 1.5, which is just 3.5. So our amplitude is just going to be 3.5. Now, what's the period of our function? Remember, the period represents when you complete one cycle. Now, right over here, this looks like it completes one cycle, right? Right? We're back at the same spot, and it's like heading at the same direction. However, the problem is that we don't know what this point is. But what we do know is that halfway through, we go to 15. So if this distance right over here is 15, then this rest of the distance right over here also has to be 15, okay? What we got to know is that sort of the intervals are the same throughout the periodic function. So the distance from the middle point to the lowest point is going to be the same as the distance from the lowest point back up to the middle point, and it's the same as the distance from the middle point to the highest point. All of these distances right over here are going to be the same. So if this right over here is 15, well, we can say that this distance from here to the next one is also going to be 15, meaning that our period is going to be 2 pi divided, our period is 30. That's going to be our period, right? This 15 plus 15 is 30. So 2 pi divided by 30, that's just going to be equal to pi over 15. And our horizontal shift. So basically, right, if we have an original sine graph, right, it looks something like this. Now, if I subtract 1 from it, well, what do you notice? Well, it moved to the right by 1 unit. So the easiest way to tell that the sine function moved either left or to the right, so either to the left or to the right, is that normally the sine function hits the middle, right? Normally the sine function hits the middle of it, so it hits the midline at y is equal to 0. So at the y-axis right over here, notice how the sine function hits the midline, or the middle point, right, at y is equal to 0. And in this case, right over here, right, that's still the case, right? We still hit the middle line at y is equal to 0. Therefore, we didn't actually move it. So our c value would be 0, right? Because we didn't actually move it left or right. All right, so that's something important to know. We didn't actually move the function left or right. So that means that there's going to be no horizontal shift in our function. All right, determine the minimum and the maximum of this function. Y is equal to 8 cosine of x plus 3. So normally, what a normal cosine function looks like is something like this. It looks something like this, where it oscillates between 1 and negative 1. Basically goes up and down, where the maximum point is 1, minimum point is negative 1, okay? Goes in between these values. Now, what this 8 does is it's the amplitude, right? Now, all right, so imagine if we only had the function y is equal to 8 cosine x, okay? Imagine if we just had this function. It would look something like this. Now, this isn't perfect, but it would do the trick. All right. Now, we know 8 right over here, this represents the amplitude. Now, originally, in our cosine function, so in our yellow graph right over here, so our yellow graph right over here is y is equal to cosine of x. And notice how you can write it as y is equal to 1 cosine of x, because this 1 represents our amplitude, right? Our midline for this function, so if our highest point is 1 and our lowest point is -1, well then the kind of line in between, our midline, is going to be at 0, right? Because 0 is in between 1 and -1. So that means our amplitude is 1, right? Because the distance from 0 to 1 is just 1, which matches up with what we originally had here. Now, if we have y is equal to 8 cosine of x, well, we aren't changing the midline, right? Our midline stays the same, but now the distance from our midline to the highest point is now 8. So in this case, our highest point is going to be 8, and our lowest point is going to be -8, right? Because now we oscillate around 8, but we also have to go 8 units downwards, right? We go 8 units upwards, but we also have to go 8 units downwards. So our highest and lowest point is going to be 8 and -8. Now, if we add this plus 3, all it's going to do is it's going to move every point on the graph by 3 units, right? If I can show y'all in decimals, right? If we have the graph of cosine of x, we just add 3 to it, it just moves everything up by 3. Therefore, originally our maximum point was at, originally our maximum point was at 8 and -8. However, if we add 3 to the function, well, our maximum point is going to move up by 3. So maximum point is going to be at 11. And our minimum point is also going to move up by 3. So it's going to be at -5. So that's going to be the maximum and the minimum for this function. So whenever you have a cosine function, right over here, we said how cosine functions, or sine functions, all right, this applies to both sine and cosine functions. But we said how it can be written in this form, right? To find the maximum of this function, well, we know that the amplitude right over here, we have the amplitude right over here, and what we're going to do is we're just going to add our amplitude, so our amplitude plus our midline, and that's going to give us the maximum point, okay? Now, to find the minimum point, what we do is we take our midline, and subtract our amplitude, right? Yeah. And that's going to give us the minimum point, right? Because think about it, right? Our amplitude has an effect of our maximum point, right? Because there's an 8 cosine of x, this moved the maximum up by 8 units. And in addition, this plus 3 at the end moved everything up by 3 units. So we saw how 8 plus 3 gave us 11, right? But to find the minimum point, what we did was we said, okay, our midline is at plus 3, right? Because this plus 3, it's the midline. So basically our midline changed from 0 to plus 3, right? And to find the minimum point, well, we have to go 8 units below. We have to go 8 units below that midline. So we get the minimum point. So in this case, notice how 3, in this case, our midline minus our amplitude. So 3 minus 8 gives us -5, which we said was the minimum point. Find an angle in each quadrant with a common reference angle with 150 degrees from theta ranging from 0 to 360 degrees. Now, what is this question even asking us? So first of all, right, 150 degrees looks something like this. All right, this is 150 degrees. All right, now what's the reference angle for 150 degrees? Well, the reference angle, remember, it's just the angle that's formed with the x-axis and the terminal side of the angle. So it's this acute angle right over here. So look, this ray right over here represents the terminal. I'll just say the terminal side of our angle, right? Now, notice how it forms an acute angle with the x-axis. And this represents the reference angle. All right, so even though this angle is obtuse right over here, the reference angle is always going to be an acute angle, right? It's always going to be less than 90 degrees. So the reference angle in this case is going to be 30 degrees because 150 plus 30 gives us 180, which represents the angle for just a straight line. So basically what this question is asking us is find an angle in each quadrant with a common reference angle with 150 degrees. So we know that 150 degrees, the reference angle for 150 degrees, we said how it was 30 degrees, right? So basically what this question is saying is find an angle in each quadrant with a common reference angle of 30 degrees. All right, so imagine if each quadrant right over here, had a reference angle of 30 degrees. All right, and we want to find the angle that creates that. So in this case, for our first quadrant, for for quadrant number 1, the reference angle is just going to be the angle itself. So for quadrant 1, it's 30. Now for quadrant 2, which is represented by this angle right over here, so quadrant 2 is just going to be this angle right over here, right? That creates this big angle, right? This angle right over here is just going to be 180 minus 30, right? Because this whole thing is 180, and we have the 30 right over here, and that's going to give us the remaining part of our angle. So 180 minus 30, that's 150. That's going to be for quadrant 2. For quadrant 3, we're talking about this angle. For quadrant 3, we're talking about this angle right over here. So notice how, right, to find the reference angle, all we have to do is we take 180 degrees and add it on to 30 degrees, right? Because I'm switching a lot of colors here, but notice how this right over here is 180 degrees, and this right over here is 30 degrees. So if we just add these two angles up, well, we would get this whole entire angle, which is in this case 210. Finally, to find the last reference angle, we know that a whole trip around the circle is going to be 360 degrees. And in this case, I'm trying to find this angle right over here. So this blue line represents my angle, right? And then it has a reference angle of 30 degrees. Notice how the whole thing is 360 degrees minus my reference angle, right? To find out this blue part right over here, it's going to be the whole thing minus my reference angle. So 360 minus 30 gives me 330. And that's our answer. All right, so let's say if I want to convert from degrees to radians. So in this example, I want to convert 5 degrees into radians. And both of these are a measure for angles. So in this case, I take my 5 and I say that in pi radians. So in pi radians, there's 180 degrees. Now, if you want to know why that is, check out my video on it. But basically, so 5 divided by 180, that's going to be equal to, okay, 5. So 5 divided by 180, I'm pretty sure that should be, so we should get pi over 36. Because 5 divided by 180 gives me 36, and pi times 1 over 36 is just going to be pi over 36. Now, if we want to get from radians back to degrees, so let's say degrees. Now, when you're dealing with radians, usually there should be a pi in it. So let's say if I want to convert 3 pi over 4 into degrees. Now, that doesn't always have to be the case, okay? I'm saying normally the radians they have a pi. And if the radians do have a pi, your job is really easy. Because what you do is you literally just flip this around. You use kind of the reciprocal conversion factor. You just say that in 180 degrees, there's pi radians, right? And then notice how the pi's cancel out. So in this case, you're just going to be left with an answer without a pi, which is what a degree, right? Which is what degrees are measuring. In this case, this would be 135 degrees. I use my calculator because I'm lazy. But that's the basis, okay? So to convert from degrees to radians, multiply your thing by pi over 180. If you want to convert from radians to degrees, just flip that around. 180 degrees in pi radians. And there you go. All right. So the final kind of thing we want to talk about is quadrantal angles. Basically, on a unit circle, there's 4 key points to know about. You have this point, this point, this point, this point. Now, let's say if I create a 90-degree angle on a unit circle. What's sine of 90 degrees? I want to find out what's cosine of 90 degrees and what's sine of 90 degrees. Notice how cosine represents the x value. So this represents the x value of my point. Sine represents the y value of my point. Now, since this is a unit circle, the unit circle has a radius of 1. So if I'm only going 1 unit up, the coordinate of this point is going to be 0, 1, right? Because I'm only going 1 unit up. I'm not moving left or right. I'm just going 1 unit up, it's 0, 1. Cosine represents the x value, so it's 0. Sine represents the y value, so it's 1. If you have 180 degrees, so if you have an angle of 180 degrees, notice how you're going 1 unit to the left. So this point right over here would have the coordinates -1, 0. So that means that if I were to create a 180-degree angle, this right over here would be cosine of 180, because that's the x value. This would be equal to sine of 180, because it's the y value. If you have a 270-degree angle, you can kind of see where I'm going. 278-degree angle, you're going 1 unit down. So in this case, this will just be this would be 0, negative 1. And the reason why it's 1 unit is because it's the unit circle, and the unit circle has a radius of 1. So this right over here is a radius of 1, right? So yeah. So this means that cosine of 270 is equal to 0 because that's the x value. Sine of 270 is equal to negative 1. And if we go all the way around the unit circle, 360 degrees, well, this point right over here, this point is 1, 0 because you're going 1 unit to the right. So now that's cosine of 360, sine of 360 is going to be equal to 0. And it turns out that that's actually the same scenario. If you create a 0 degree angle, so if I have cosine of 0 degrees and sine of 0 degrees, this would actually be the same answers. So cosine of 0 is equal to cosine of 0 is equal to cosine of 360, which is equal to 1. Sine of 0 is equal to sine of 360, which is equal to 0. The reason why is because, look, imagine if you're on the unit circle, right? So let's say if you have some angle on the unit circle, right? It hits the unit circle at this point, at this specific x and y value. And you go 360 degrees around the unit circle, which is just 1 rotation. And notice how you end up back at the same point. Therefore, the x and y values are the same, which means the cosine and sine values have to be the same as well. So the important trig identity to know is that cosine of theta is equal to cosine of theta plus 360. Or 2 pi if you're dealing with radians. But that's an important thing to know. And this also applies for sine. Finally, an important thing to know is that sine of 90 degrees minus theta. So now we're in degrees. So sine of 90 minus theta is equal to cosine of theta. All right, so for example, if I have sine of 33 degrees, this is just going to be equal to cosine. This is equal to cosine of 57 degrees. Notice how these two values add up to 90 degrees. All right, and I'm pretty sure I have a video on that. I forgot which video I put it in, but I should have a video on why that is. So let me just kind of give you a quick practice problem. So if I have sine of x plus 1 is equal to cosine of 66, how would I solve this? Well, I would just set the inside of the function. I would add these two values. So x plus 1 plus 66. I add the inside values, and I set it to 90, right? Because that's the trig identity, right? You're supposed to set it to 90 degrees. So now this is 67, and after that you get x is equal to 23.